We're doing something called factoring by grouping right here. So what I'm going to do is I'm actually going to take these four terms right here and I'm going to put them into two different groups. And if you notice the way that they're written right now, 2m minus 27 or 2m cubed minus 27, you can't quite factor because 2 goes into this one and 27 doesn't. Now, if we were to strip down m cubed minus 27, I think we actually could because this is a perfect cube. And so is this, and that actually might come back to help us later on. But what I want to look at is the fact that this coefficient's even, as is this coefficient right here, and they both have an m. So I'm actually going to list those out together, 2m cubed minus 18m, because the fact that they have those things in common it might be a coincidence, but it might not. And I'm going to do the same thing here. 27 and 3 have something in common. So I'm rewriting this, and I kind of want to put this variable first. Let me rewrite it again. And the reason I rewrote it, it's not in standard form. You can probably tell because this one right here, the degree is 1, and this term right here, the degree is 2. But when I do start factoring them, they're going to be written as factors at least in standard form because the variable will be first here and the constant will be last. So you can probably see I'm going to take a 2m out of both of these terms, and when I do, I'm left with just m squared right here, because if I did m squared times 2m, that would equal 2m cubed, and then right here that would be a 9. And then for this one, it looks like we've got an addition sign right there. I can factor out a 3, so the 3 goes on the outside, and we're left with m squared minus 9. So this is a unique situation in math. When we had normal numbers, let me just do this in green over here. Like if I said to you, I've got 6 and I'm multiplying it by 3, and then I'm going to add that with 4 multiplied by 3. Well, in the old days, you'd say 18 and 12 gives you 30. But you could also, hopefully you recognize that this, with the distributive property anyway, 6 groups of 3 and 4 groups of 3 is the same as 10 groups of 3, and you could have just called it 30 that way. Well, in the same way, I'm multiplying 2m by this, and I'm multiplying 3 by this, and this number is the same. So I could just say, right here I got 10 by doing 6 plus 4, so I could just say, instead of adding 6 and 4 because I know what those numbers equal, I got to leave this as a plus sign, 2m plus 3 here. And then the other number, the 3, as you notice when we did it with actual numbers, that didn't change, that stayed there. So I'm going to keep my other number there, m squared minus 9. And you've just factored by grouping. Now, we can take this another step further. If you notice it says m squared minus 9, I can actually break that down because it's a special case where you can take the square root of m squared, you can take the square root of 9. And so we get m minus 3 and m plus 3. And you also have 2m plus 3 right here. Now, just to check this, because that's a lot of thinking that went into that, if I was to multiply this all together, well, we know this part's going to be negative 3m and positive 3m, they're going to cancel. We know this part right here is going to equal m squared minus 9, so that checks out okay. And then as far as the other part, 2m times m squared, it gets you that 2m cubed. 3 times negative 9, it gets you that negative 27 right there. And the middle terms, this is 3m squared, there it is right there. And then negative 9 times 2m, there it is right there, negative 18m. So everything checks out okay. Let's try one more. And again, it looks like I've got a common factor right away right here. So I can factor that out. I don't need to rewrite this. It looks like anyway. Y squared, I can take that out. So y squared times y gets me the y cubed. And I took out y squared, so I'm just left with negative 9 right there. And I'm adding y minus 9. So I've got that written down twice here. It would be like saying if we had 4 times 3 plus 1 times 3, or just plain old 3, that would be 12, and then another 3 gives me 15. In this case, I'm going to call it 1 times 3. I've got one group more of y minus 9, so what I can say is I'm really multiplying this all by 1 here. So if I did that, well, you're going to have y squared plus 1 times y minus 9. Now, let's check again. There's a lot of math that went into this. So 1 times 9 is negative 9. That checks out. The y cubed, y squared times y is y cubed. 1 times y is plain old 1y. If you want to put the coefficient here, you can. And then negative 9 times y squared is negative 9y squared. So that it all checks out. And actually, you can't simplify this one further. It's tempting to say you can make this y plus 1 and this y plus 1 because you see the y squared and you know that y squared obviously is a perfect square, and same with the number 1. But the problem is the middle term becomes 2y because there's nothing to cancel out here. And this one is also tempting, but you can only find the square root of 9. You can't find the square root of y. That would give you a radical. So let's just leave it as this right here.